So we're going to raise the value of the highest power from 3 to 4 and look at roots of quartic equations. This is as messy as it's going to get, but we're going to approach this in just the same way. So we start off by saying if a generic quartic has roots alpha, beta, gamma and delta, then by the factor theorem it must factorize like this, and the a out the front ensures our leading coefficient is a as it needs to be. So just as before, we're going to expand that entire right hand side in order to compare coefficients. So because it's going to take up a lot of room, I'm just going to do the expansion of the right hand side here. So our right hand side is a times, okay, what have we got? Well, we've got an x to the power of 4. What about our x cubes? Well, our x cubes will come from when we take x, 1, 2, 3 of the brackets and the constant from the other. So you can see it's if I take x, x, x and minus delta, I get minus delta x cubed. If I go x, x minus gamma x, I'll get minus gamma. And the pattern continues. What we're going to get here is x cubed times minus alpha minus beta minus gamma minus delta. Okay, now for the x squares. This one's probably the fiddliest one. So for the x squares, we need to think of all the different ways that we could choose 2 of the brackets to take an x squared from and to take the constants from the other 2. So it's basically every possible pair of constants we could get. So that would be alpha, beta. Now positive because the negatives cancel. It'll be alpha, beta when we take constant, constant, x, x. Then it's alpha, gamma. That would be if we took alpha, constant, x, and so on. We need all 6 pairs. So alpha, beta, alpha, gamma, alpha, delta. Then we need beta, gamma, beta, delta, and gamma, delta. Right, let's do a plus dot, 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 and continue down here. Then it's the x's, and we get the x's when we take x from one of them, and then the 3 remaining constants. So we can just think about which constant do we miss out in each case. So if I missed out the delta and took alpha, beta, gamma, and this x, I would get minus, because it's a triple negative, minus alpha, beta, gamma. Next, there would be alpha, beta, delta. Then we'll get alpha, gamma, delta. And finally, we'll get beta, gamma, delta. So there's 4 of those. Last but not least, we get the constants. That's just minus alpha times minus beta times minus gamma times minus delta, which is plus alpha, beta, gamma, delta. Okay, what an enormous mess we've got here. If we compare coefficients though, what we'll have is the leading coefficient ax to the 4 is ax to the 4. That's fine, doesn't need anything written down. Then we get b must be equal to a times all of the negatives added up. Dividing through by minus a, what we get is minus b over a must be equal to alpha plus beta plus gamma plus delta. So that's the same as all the others. Always the sum of the roots is minus b over a. Next then, the coefficient of x squared. Well, it's c here and it's a times all of this stuff here. So dividing through by a, we get positive c over a is the sum of the pairs, just as it was with a cubic, it's just there's more of them. So positive c over a is alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta. Next, the coefficient of x, which is d here, and it's a times all of the triples here. Dividing through by minus a, we get minus d over a is the triples. So that's alpha, beta, gamma, plus alpha, beta, delta, plus alpha, gamma, delta, plus beta, gamma, delta. So minus d over a with cubics was also the triples, but there was only one triple. That was just the product of the roots. Finally, we're on to the product of the roots for the quartic, whose coefficient is e here. And on the right-hand side, it's a times alpha, beta, gamma, delta. Dividing through by a, we get e over a equals alpha, beta, gamma, delta. Okay, here's a little neater summary of this. That's a lot to write down. So usually we write these down in the following way. We'll just say the sum of the roots on their own is minus b over a, and you know that means alpha plus beta plus gamma plus delta. Here we say the sum of the pairs. That's all 6 pairs of roots. That's c over a. The sum of the triples, all 4 triples, is minus d over a, and then the product of all 4 is e over a. Okay, with all of that in mind, let's actually look at a quartic or two. So we're going to just jump in at the deep end here. The roots of the equation x to the 4 plus 3x cubed plus 2x squared minus x plus 4 equals 0 are alpha, beta, gamma, delta. Find the sum of the reciprocals. Okay, well, our strategy here is similar to what it's been before, which is just get this all as a single fraction. The common denominator is alpha, beta, gamma, delta. What do we have to multiply top and bottom by here? We had to multiply by beta, gamma, delta. So that's beta, gamma, delta. We have to multiply top and bottom here by alpha, gamma, delta. We have to multiply top and bottom here by alpha, beta, delta. And finally, we had to multiply the last one by alpha, beta, gamma. That's just the sum of the triples. So what we have is the sum of the triples over the product of the roots. So that's the sum of the alpha, beta, gammas over the sum of the alpha, beta, gamma, deltas. And now we can just find what those actually are. So alpha, beta, gamma, the sum of those is minus d over a. Well, let's explicitly write down our a, b, and c, and d, and e. Our a equals 1, our b equals 3, our c equals 2, d equals -1, and e equals 4. So the triples are minus d over a, so that's minus 1, so 1 over 1, that's just 1. And then the sum of the quadruples, or the product of the roots, is e over a, that's 4 over 1, that's 4, and there's our answer. So the sum of the reciprocals is equal to a quarter. Of course, you could check this, right? You could use your calculator to actually find all of the roots here. Maybe some of them are complex. You could then just by hand work out the reciprocals of all of those and add them up. It's a lot of work, but you can do it if you want. Okay, well, I'm not going to do any more of roots of quartics. They are rather enormous. They're not really harder than the cubics or quadratics. They're just a bit longer and messier. Sadly, you do not get given these formulas, right? Whatever specification you're doing, you do have to remember all of these. So it is unfortunately quite a lot to remember, but the rules are actually the same for all of them. It's always the case that the sum of the singles, the sum of the roots, is minus b over a. The sum of the doubles, whether it's quadratics, so that's just the product, or cubics or quartics, is always c over a, then minus d over a for the triples, then e over a for the quadruples. So really it's just 4 things to remember. It's just that if you have quadratics, you're only using the first 2. If you're having cubics, you're only using the first 3. If it's quartics, you're using all 4. Okay, so we've now looked at quadratics, cubics, and quartics. The next thing to look at in the next video is how to then combine these to find new equations. I'll see you in the next video where we'll explore that.